Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izul Khairi bin Sapil Badi. Today I'm going to present to you the introduction of our PBL project. First, this lecture will discuss types of application where ordinary differential equations were used, namely population growth. The key concept of exponential growth is that the population growth rate, the number of organisms in each generation, increase as the population gets larger. In exponential growth, a population per capita, or in bracket per individual growth rate, stays the same regardless of the population size, making the population grow faster and faster as it gets larger. Okay, for example, an equation dn per dt equal to Rn. Dn per dt is the growth rate of the population is given in instant. N is population size, T is time, and R is per capita rate of increase. Okay, first step, let P in bracket T be the number of population for any time T. P0 is the initial number of population, and dP per dt is the rate of population growth. The rate of growth is proportional to the number of population, or dP per dt equal to Kp, where K is proportional constant. This is the first order separable ODE, where P can be found by solving the ODE, where C is the integration constant and A equal to EC at T equal to 0. The number of population is P equal to P.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Sharom. Today I will present about minute meeting, our first minute meeting. So the time is 10 p.m. Place in Google Meet, and the attendance is first is Muhammad Hafiz Sharom, second is Muhammad Aikal bin Honan, third is Muhammad Izul Khairi bin Saiful Bahadi, fourth is Muhammad Haziq Syabil bin Mat Suhaidi. The activities we discuss in the Google Meet is: suggest and appoint a group leader for this project, understand the whole idea and problem of the problem-based learning report. The third one is giving the distribution, get a due date to send the task given of each part of the leader, need to be done before the next meeting to discuss and combine the task given. Okay, that's all for the first meeting. Okay, for the second minutes meeting is, the time is 9 p.m. Location in Google Meet. The attendance is, the first one is Muhammad Hafiz bin Sharom, second one is Muhammad Aikal bin Honan, the third one is Muhammad Izul Khairi bin Saiful Bahadi, the fourth one is Muhammad Haziq Syabil bin Mat Suhaidi. Okay, the activities that we doing in the meeting is, the first one is describe if there were any problem while doing the task given. The second one is collect all the tasks given and complete into one file report. The third one is check if there were any mistakes in the report. So that's all from me. Thank you.
This is the problem statement for part A. Based on the question given, this is an experiment conducted to observe the rate of bacterial cell growth in liquid culture. We were given the information that the bacteria has multiplied from 30,000 to 500,000 cells in the span of 3 hours. This information is necessary to solve the problem, as we need to find how many bacterial cells will be there after one full day of growth. If this unlimited growth continue, and the doubling time of the bacteria which we need to find.
For the fill-up table, in question 2, part A, we can divide the question with 4 sections, which is facts, ideas, learning issues, and resource needed. For the facts, first one, the number of bacteria in a liquid culture is observed to grow at a rate proportional to the number and cells present. Number 2, at the beginning of the experiment there are 10,000 cells. Number 3, after 3 hours there are 500,000. And second idea, first one, number of bacteria in a liquid culture is observed to grow at a rate proportional to the number of cells present. Number 2, there are 10,000 cells, and after 3 hours there are 500,000. After that, learning issues. Number 1, how many will there after 1 day of growth if this unlimited growth continues? Number 2, the doubling time of the bacteria. And for last segment is resources needed. First, group discussion. Second, mathematical formula, and third one is internet.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Sharum. Today I will present about question 2, part A. Okay, in this question, we have two questions that was given. Okay, we need to solve the question A first. We need to get the equation like this. 2b over 2t equal to c. And then we need to integrate. We will get b equal to ct plus c1. Given b equal to 500,000, t equal to 1, c equal to 10,000, and then we will get like this. 500,000 equal to 10,000 times 1 plus c1. c1 equal to 490,000, b equal to ct plus 490,000, and then equal to, in bracket, 10,000 times 54 plus 490,000, b, and then we will get the answer like b equal to 730,000 bacteria. Okay, for the solution for question B, we will get the equation like this. 2b over 2t equal to 10,000 equal to c. Okay, we will get like 10,000 bacteria per hour. And then we need to do 2b equal to 2 times 500,000. And then we will get 1 million equal to 10,000 times t plus 490,000, and then we will get the t equal to 51 hours.
Moving on to the problem background of part B. This problem is based on the psychologist's discovery on the topic of the limit to the number of meaningless words that a person can learn. The basis of this problem is the amount of study time available is trivial, and the rate of learning is only proportional to the number of words not yet learned. Assuming that the limit is 100 words, a differential equation is satisfied by the rate of learning and is written to be dw over dt equal k open bracket 100 minus w close bracket. We were required to use separation of variables to find the general solution to this equation. We were also required to find k if the beginnings no word have been mastered, and after 5 minutes, 30 words have been learned.
For question 3 part B, in fill table, we can divide by 4 segments, which is fact, ideas, learning issues, and resources needed. The first one is facts. First, the equation, the velocity of an object moving through a fluid can be modeled by equation dv per dt equal to negative kv square. And the second one is ideas. First one, let v in bracket t be the number of velocity in t time. Second, where k is proportional constant, this is a first order separable, ODE, where v can be found by solving the ODE. And the third one is learning issues, and the first one is the first learning issues is the general equation, and the second learning issue is the velocity after 10 seconds. Okay, the resources needed, we got 3. The first one is group discussion, the second one is mathematical formula, and the third one is internet.
Okay, I will present the question 3, part B in solution. In this question, we have two questions. We need to solve the question A first. Okay, in question A, we need to get the equation dv over dt equal to negative kv square. After that, we need to integrate the equation. And then, we will get ln v equal to negative kt plus c. After that, we need to get rid of the ln. And then, we will get v equal to e the power of negative kt plus c, and then we will get v equal to e the power of negative kt e the power of c, where a equal to e the power of c, and then we will get v equal to ae the power of negative kt. Okay, when t equal to 0, v equal to ae the power of negative kt, ae the power of negative k equal in bracket 0 equal to VO, A equal to VO. Okay, we get the answer V in bracket T equal to VOE, the power of negative KT is the equation of decay model. Okay, I will present about the solution for question B. Okay, first of all, we need to do the step 1 first. Given V in bracket 0 equal to 40, and then we will get VOE, the power of negative K in bracket 0 equal to 40. VO in bracket 1 equal to 40, and then we will get VO equal to 40. In the update, we will get V in bracket T equal to 4E, the power of negative KT. Okay, the step 2, given V in bracket 2 equal to 30, and then we'll get 40 e the power of negative k in bracket 2 equal to 30. E the power of negative 2k equal to 30 over 40. And then we will get ln e the power of negative 2k equal to ln 30 over 40. Okay, we need to solve the k, and then the equation will be like this. K equal to in bracket ln 30 over 40 over negative 2. And then we will get the k equal to 0.14385. Okay, for the step 3, we need to do v in bracket t equal to 40 e the power of negative in bracket 0.14385 t. After that, if we use the 10, v in bracket 10 equal to 40 e the power of negative 0.14385 in bracket 10, and we will get the answer 2.25. Okay, the final answer is v equal to 2.25 meter per second. Thank you.
For the discussion and conclusion, in this investigation, we must solve two questions. One is about population growth, which is the question is about bacteria growth and the doubling type of the bacteria. For part B, the question asks for the general solution. An object moving through the water has an initial velocity of 40 meter per second. 2 seconds later, the velocity has decreased to 30 meter per second. What will the velocity be after 10 seconds? This program-based learning project makes it clear that for both questions, we need to elaborate the question clearly so we can come up with the correct equation. We need to think critically to find the correct first equation to solve the question. We need to collect all the important details from the question to get the final answer. So for the conclusion, we can conclude during the program-based learning project, we have solved a kind of statement problem which can make we more understand during this topic all the idea skill we provide to make this project successfully. So I hope we can continue apply our knowledge in daily life. Thank you.